Hello everyone, and thank you for joining our webinar today on climate and weather tools for stormwater planning in the Great Lakes region. This webinar is brought to you by GLISA, the Great Lakes Integrated Sciences and Assessments. I'm Kim Channel, one of GLISA's climatologists, and I'll be facilitating most of today's webinar. We have a pretty packed agenda today. This was originally planned to be an in-person workshop for about 20 to 30 people back in the spring, but when COVID hit, we had to move it to a virtual format, and we were not about to make anybody sit on a day-long webinar, so we trimmed down as much as we could so that we could get it into this 3-hour format that we have today. So essentially, this is the light version of what the in-person workshop would have been if we had been able to hold that. So we'll be starting with a brief overview of the webinar and why we're holding it, and this will include an overview of precipitation trends for the region, as well as a little background on GLISA. And then next we'll get into our tools session, starting with 4 tools presentations from experts who know them very well, and some even work on developing the tools so they can answer your questions about them. And then we'll be doing a 20-minute virtual tools cafe, if we can pull it off with no technical problems. And during this time, there will be breakout rooms for each of the tools led by the tool presenters. So this is your chance to ask them more in-depth questions or demo the tool yourself, pull it up on your own screen, learn how to use it. And then after that, we'll be doing a short live interactive survey together about the tools and what you think of them, just getting your overall feedback. And then for our last hour, we'll be joined by 3 stormwater practitioners from around the region who have a lot of experience that they can speak on, and this will be an open Q&A format. It will be more of a discussion, open discussion that you can submit questions to. And since 3 hours is still a pretty long time and we don't want any of you getting webinar fatigue, we will be taking a 5-minute break at the top of each hour. So one in the middle of the tools presentations at 2 p.m. and another right before the panel at 3 p.m. So we bring you this webinar today as part of a much broader national effort. This is actually one of 7 workshops being held in different regions across the country as part of a year-long project with the National Oceanic and Atmospheric Administration Sectoral Applications Research Program, or NOAA SARP. The project is called Filling the Gaps, Climate and Weather Information for Small and Medium-Sized Water Utilities, and it has the following project goals: to better understand the information needs of water utilities, to identify gaps to expand and improve NOAA climate and weather related tools, to raise regional awareness of the NOAA tools that are available for use, and to build regional connections that support small scale utility decision making. So 7 different teams were asked to coordinate a workshop tailored to their region, and GLISA was asked to host the Great Lakes workshop. Many of the other workshops in this project for other regions are being coordinated by our RISA network counterparts. So the RISA, or Regional Integrated Sciences and Assessments Program, is a network of 11 regional teams supported by the NOAA Climate Program Office. These teams are dedicated to helping the nation prepare for and adapt to climate variability and change. And GLISA is the Great Lakes RISA program. We're a partnership between the University of Michigan and Michigan State University. And since 2010, our team has served all 8 US states that border a Great Lake and the province of Ontario, Canada. The GLISA's team of physical and social scientists works together to increase the use of climate information by decision makers in the Great Lakes region in order to inform climate adaptation. And while we do work in a number of sectors, we primarily work in cities, tribes, and agriculture as our main focus areas. And we take existing information like climate models and data, and we synthesize it for stakeholders in a way that is usable, useful, and salient, typically doing this by tailoring information to specific locations to better meet end user needs. And in doing this, we ask 3 questions. What has happened? So historically, how has the climate already changed? What will happen? What do climate models project for the future? And what are the impacts that communities actually experience? And our ultimate mission is to help stakeholders, local officials, urban planners, policymakers, resource managers, and so on use climate information to make more informed decisions in the face of climate change. And since GLISA is the RESA program for the Great Lakes, we were asked to coordinate the workshop for our region. And each different region of this project has different water needs and different problems that they face. So each workshop evolved according to those more customized water needs. So all of them turned out a little bit different from each other with their own focus areas. So how did we get to stormwater as the focus for the Great Lakes workshop? Well, water utilities in other regions of the country may face challenges related to, say, drought or water availability or sea level rise, but here in the Great Lakes, certain types of water utilities like drinking water or wastewater just aren't necessarily affected in the same way by weather events or climate trends as they are in other regions of the country. Because here in the Great Lakes, we face a different set of water challenges driven by our fairly unique regional climate. And I can tell you that the majority of project and data inquiries that GLISA receives from stakeholders and partners in the region is about flooding. It's about extreme rainfall, it's about precipitation trends. So why is this? Well, for one, annual precipitation has increased in our region. It's increased by an average of 14% since 1951. And this is just the Great Lakes wide average. There are spatial and seasonal variations in this number. So Southeast Michigan, for example, has seen a 17% average increase in annual precipitation, whereas the western upper peninsula of Michigan has actually seen a slight decrease over the same time period. And these are just average numbers again. And we're also seeing more winter precipitation falling as rain rather than snow as we see winter temperatures rise. So really precipitation is just not changing in a uniform way across every location and every season. And that makes it very important to get locally customized climate information. And extreme precipitation events are also increasing in the Great Lakes. So the volume of rain falling in the heaviest 1% of precipitation events each year has increased by an average of 35% since 1951, with pretty significant spatial variations based on location. And the frequency of these events has increased as well, meaning that they're occurring more often as well as at a higher intensity. But to really understand the increases in extremes, particularly with rainfall, you have to zoom in more on the local scale. So this map shows that those more local scale changes from individual station observations. So here you can see the percent change in the intensity of the heaviest 1% of precipitation days each year. And this is the difference between those events of the 1981 to 2010 climate normal period compared to the 1951 to 1980 climate normal period. The red dots represent increases between those two time periods, blue dots represent decreases. And then the larger the dots are, the higher the percent change. So these large red dots that you see all over the region correspond to pretty major increases in extreme precipitation intensity over the last few decades. Now, these are all region-wide climate trends, but what communities actually feel are impacts at the local level. So the increases in extreme precipitation that we are seeing can overwhelm stormwater drainage systems, lead to flash flooding, damage roads, bridges, other infrastructure, and this can in turn interfere with transportation and emergency services during extreme weather events. And it can also cause erosion, especially along shorelines and rivers where flows or waves increase during a storm. And some municipalities have combined stormwater sewage systems, so an overflow during a heavy rainfall event could lead to water quality and public health issues in the most extreme situations. And cities also have to rely pretty heavily on stormwater drainage systems because of all the impervious surfaces, all the concrete, otherwise that water would just have nowhere to go. But even these systems can be overwhelmed by a large enough volume of rainfall. And again, this is the most common topic that GLISA gets inquiries about. It's one of the more immediate, tangible impacts of a changing regional climate. And we have a lot of older stormwater systems in our region built based on historic precipitation trends and design storms. and they just don't have the capacity to necessarily handle these larger amounts of rain that are falling in these events that we're seeing more and more often. So many cities and municipalities around the region are starting to pursue adaptation efforts. They're looking into their stormwater infrastructure, and they're working with programs like GLISA to get locally customized climate information. And at the heart of it, that's where adaptation begins. It's being educated on the risks and the changes so that you can plan and prepare to make the necessary changes and mitigate the impacts in the future. So we hope that today will be a helpful step for many of you to be introduced to some tools, information, or discussion that can help you start down this path. And that is why we chose to focus our workshop or our webinar today on stormwater and tools that are relevant to stormwater planning and management. So the increasing trends that we've seen in precipitation and extremes are projected to continue into the future, and coping with the impacts of this is going to require planning, and it's going to require adaptation efforts. And to do that, you need to be informed on what you're facing. There were dozens of tools that we could have shown you today, but we decided to focus on a handful of tools that were relevant to stormwater planning. But this webinar is still open to anybody because these tools are relevant to plenty of other applications as well, but that is why we chose to focus on stormwater for our webinar today. That's the background of how we got here and why we have the focus that we do, but we're going to get started into our tools session now. So here's the breakdown of how this will go. So we'll have 3 tools presentations before we have our first 5-minute break. So these tools will be NOAA Atlas 14, NOAA Quantitative Precipitation Forecast, and the NOAA Climate Explorer. Then after a 5-minute break at 2 o'clock Eastern Time, we'll have our final tool presentation on the EPA Stormwater Calculator. And there's going to be a few minutes for questions after each of the tools, so please enter any questions you have into the chat box, and we will address them at the end of each presentation. Then we'll attempt to have a virtual tools cafe, then complete the tools survey together, take another 5-minute break, and then we'll get to our stormwater panel at 3:05. And I do want to note that we have overviews of each tool available on our website at the link posted here. The link is also on the event page for this webinar, where most of you probably went to the registration page through, and we'll also put it in the chat box here in a moment. So this would have been a physical handout if this had been an in-person workshop, so we're just giving it to you virtually instead. So it has links to the tools, descriptions on the information and the data that they provide, and an explanation of how to use them. It's really meant to complement the presentations you're about to hear today so that you have something to refer back to after this is over. And we'll also be sharing the slides from all the presentations that you're about to see after the webinar. So let's get started. Up first, we have Michael St. Laurent out of the NOAA Office of Water Prediction at the National Water Center. He's joining us today to give an overview of NOAA Atlas 14 point precipitation frequency estimates. We also have Mark Glaudemans from the National Water Center on, I think, to answer questions with Michael after the presentation is over. So Michael, you can go ahead and unmute your mic and your camera, and you can take over screen sharing to tell us about Atlas 14.
Thank you, Kim. So thank you for having us today. I'm going to do a short overview on NOAA Atlas 14, some of the applications, and go over our website and how to get the data. So what is Atlas 14? Atlas 14 are precipitation frequency studies done in the United States and various territories. They are point precipitation amounts for a given duration and annual exceedance probability. You've also heard maybe average recurrence interval or return period. So for example, if you're looking for a precipitation amount over a 24-hour period with a 1% annual exceedance probability. So since 2004, there have been studies published online for various volumes of NOAA Atlas 14, and in the bottom right here is just a overview map of the different volumes, and you can see they're a bit piecemeal, and I'll go over that a little bit more later. These are done by the Hydrometeorological Design Study Center, or HDSC, and we develop these updates for the United States and territories. We're part of the Office of Water Prediction in the National Weather Service, And this work is performed at the request of users and funded by users, which is part of the reason why you see the different volumes here scattered. There's no dedicated funding source for this work, so it's done as requested. So what are some of the applications of this work? Mainly infrastructure design and planning for different regulations. This could be transportation or building codes. And in the bottom left corner, I have just from a random textbook, highway culvert for a high traffic area. It calls for a design in this example of 50 to 100-year average recurrence interval. So this is just one area where you'd go to our website and grab the specific precipitation amount that would correspond to this. They can also be used in FEMA National Flood Insurance Program. And on the right here, you can look at observed and forecasted precipitation and compare it with the Atlas 14 values to estimate severity of storm events. And in this case, this is a post-event analysis of Hurricane Harvey precipitation amounts. And many of the point estimates exceeded 1,000-year average recurrence interval. So instead of having everything in terms of inches, you can have it in terms of a historical context. One of the more recent volumes, actually our latest volume in Texas, as you can imagine, when we update these estimates, this leads to revisions of standards. In Austin, Texas, did a preliminary analysis, and their 500-year floodplain is now approximately the 100-year floodplain. And the 100-year floodplain increased by 26% in area, and the number of buildings in the floodplain doubled to about 6,500. So as you can imagine, this can affect a lot of people and property. And the bottom left is just an example of the current NOAA Atlas 14 estimate compared to the previous NOAA estimates that were done in the 60s in this region. So there's significant increases of precipitation frequency. Next, I'm just going to talk about the website and how to actually get these estimates. I have a link here in the slides, and I'll go over that later. But if you were to go to the website and click on the data server here, and for this example, I'm going to focus on Michigan, you'll get sort of a website that looks like this, and I'll zoom in a little further. So to get information, once you're here, you can either input latitude and longitude manually. You can select a rain gauge if you specifically know a rain gauge that you want, or you could just search by address, or just clicking around on the map. We give a few options to change the data type. So by default, it's in precipitation depth, but a lot of times the engineers would like intensity duration frequency curves. So this is where you change that. And then you could change units to metric and time series, partial duration series to annual maximum series based. So once you select a location, below the map, the table will update. And in this case, if you're looking for the 24-hour, 100-year average recurrence interval estimate, you'd get 6.1 inches. These numbers below that in the parentheses are the 90% confidence intervals. So in this case, 4.56 to 8.24. These tabs here, if you were to go and click graphical, you'd get the same information in the table, but in a graphical format. So we have on the left some depth duration frequency curves for this location. And on the right, it's the same information except the lower and upper bounds of the confidence intervals are shown here, and it's divided up into different durations so it's not too cluttered. We also provide various supplementary information. This part of this is the documentation, which is a technical document for how each volume is developed, and gives sort of all the stations involved, the methodology, etc. This is in a PDF format. We don't expect everybody to want to click around in a table for every point in their area, so we do provide the precipitation frequency estimates in a GIS format. In this example, if you were to click submit, you'd get a .zip file that would contain an ASCII grid that can import into various GIS software, projection information, and various metadata in an XML format. For graphical for graphical aid, we provide cartographic maps. These are just for visual aid only, and we don't expect you to try to figure out values in between contours to get the values you want. We recommend using the GIS data itself. But these are just for an overview of the area, just to see how patterns of the precipitation frequency estimates are. If you're interested in temporal distributions, we provide those in a text format. The seasonality of the extremes, we provide in a graphical format here. And if you clicked on a gauge, that gauge is time series data. Quality controlled annual maximum series will be provided for that location. So in this case, the Saginaw number 3 gauge, its annual maximum series for 1 day, 2 day, etc. would be shown here, and you can see just for an example. And then lastly, we just have a few external links to NCEI, or formerly NCDC's Climate Data Online, and watershed information from the EPA. And this information is also available on the left sidebar with a little bit of difference. So for example, time series, instead of getting just the gauge that you clicked on, you'd be able to get the entire volume's time series that went into that volume, so you wouldn't have to click on each individual gauge. Nice bulk way of downloading. Lastly, I just want to go over a few caveats of the data and some future improvements. So from the beginning, you might have noticed that there are different volumes throughout the country, and to focus on the Great Lakes region specifically, there are mainly 2 volumes that cover this area. Volume 2, which was done in 2004, and Volume 8, which was published in 2013. And on the right-hand side, you can see there's some inconsistency on the boundaries of these 2 volumes. And these are mainly due to different methodologies, but probably mostly data changes, because there was more than a decade between the different volumes. So this is one of the downsides of doing the piecemeal studies. And we'd like to address this with updating with latest precipitation data, but this would require dedicated funding to have sort of a 5 to 10 year update schedule to prevent this sort of issue. We want to add different products that have been requested by our users, such as aerial reduction factors. This just, what I've shown so far are all point estimates, but a lot of times the engineers are interested in how the estimates are over an entire area. So this converts point estimates to aerial estimates. Also an Atlas 14 design storm. And I showed earlier 90% confidence interval widths. We want to be able to provide varied widths where the user can specify. And lastly, a RESTful API. We do currently have sort of an unofficial non-standard Python API, which I'd be happy to share with anybody and talk about later if there is any interest, but a truly standard RESTful API would be ideal for our users. And for future, we'd like to test the feasibility, which we are actually doing now, of incorporating climate projections into the analysis and account for non-stationary climate. As you saw earlier, Kim was talking about the different trends in precipitation. We want to account for these. This would require a change in methodology, and it's important to note that estimates are often more affected by this change in methodology than the inclusion of a trend, but it is important to still capture this even with that. And the impact itself may still fall within those confidence limits, but that doesn't mean it's not important to incorporate these trends. So these are some of the key issues that were identified and we're further investigating. And with that, I thank you, and I'll take any questions or comments.
Great, thanks, Michael. Do we have any questions about Atlas 14 that we can get to? We have about 2 minutes before we have to start our next presentation. We do have one question, which is, How sensitive are confidence intervals to analysis method, say for a 100-year storm?
So the confidence intervals they take into account, so we group together stations to increase, sort of artificially increase the record length. So say you have a 100-year gauge with 100 years of data. You can group together 10 gauges and try to trade space for time. The confidence intervals do take into account that you don't have independence in this data. So that's that the confidence intervals will take into account that. But when you're fitting a distribution to this data, the confidence intervals do not take into account that distribution fit, because you can fit many different distributions and get many different results from that fit. For example, we use a general extreme value fit, but if you used many other fits, you can get many different answers, especially at the 100-year storm, and we actually provide 1,000-year estimates, and you can imagine there's a lot of uncertainty with those. So it does have sensitivity to those higher confidence limits. But I think 100-year, they're pretty good. It's when you start going to 1,000-year, you start getting wide confidence limits. I'm pretty confident in the 100-year.
All right, so thanks, Michael. We're going to switch over to Nancy next. Next up, we're going to have actually two tools from Nancy Beller-Sims of the NOAA Climate Program Office Sectoral Applications Research Program. She's actually a lead on this overall project, and she's been involved in planning the entire time, so she's joining us today actually to present two tools, starting with the NOAA Quantitative Precipitation Forecast and then the NOAA Climate Explorer, stopping for questions after each tool. So Nancy, you can take it away with screen sharing.
Can you see it now? Just real quick. Let me try that one.
Not yet.
Huh. As I'm doing it, give me one more second. I was resolving a network issue. Now.
Yep, that'll do it. If you can't get it in the next 10 seconds or so, I can show them on my screen and click through them as you talk if you want.
Okay. Yeah, you never know when your system's going to be overused.
Yep. All right,
okay, well,
do this now.
Thank you very much. Okay, so this is the first tool I'm going to be talking about today. Very quickly, this is the website location, and I'm going to repeat it at the end. Once you say, wow, what a cool tool, I wish I'd written that down, you have another opportunity. Okay, next slide. Okay, with the quantitative, when you go to that website, this is what you'll see. You'll be able to go into the quantitative precipitation forecast and choose the time period for what you want for you to be able to see forecasted liquid precipitation totals. What's interesting is the term forecasted liquid precipitation totals. This is how much rain falls, but in the case of snow, it's the amount of water that would have fallen if it had fallen as rain. Next slide. When you hit the day one choice, you'll see a map something like this. You can see that there's different colors, and there's a key on the left-hand side to represent how much precipitation is expected to fall. It's interesting when you look at this map that the authors or the climatologists that have it out here say that you shouldn't look specifically like for Ann Arbor just for that particular tiny dot, but that what the data is that's being shown here is basically a 20 by 20 kilometer area. And this is because, well, you probably know this in your own town or your own city, that one part of the city can get more rain than another. It could be a stalled system, whatever. So it's an average of what you're going to see approximately every 20 by 20 grid. Next slide. So the cool thing about the day one is that you can also get information not only a day ahead of time of what the precipitation forecasts are, but you can get it by 6-hour entity. So you can have over the next 6 hours, you can see the lower 5 pictures. Over the next 6 hours, this is what it's going to look like. And 6 hours later is the second picture, and 6 hours later is the third. So you're able to begin to think about what you're going to be doing over the next day or how much rain is expected to fall in your locale. Okay, next slide. There's also something further down the page when you fool around with this tool, and it's something called excessive rainfall forecast. And this provides information about the expected rainfall that might exceed a flash flood guidance that's been issued. So you can see this is for today, and you can see that the middle part of the country may have some excessive rainfall today. Okay, next slide. So the QPF, or the Quantitative Precipitation Forecasts, help you to plan for extreme precipitation events. They help you to evaluate your risk of flooding because of forecasted precipitation quantities. They help you plan for potential hazards that might hit your area. And in thinking about some of the hazards that one might see in this particular area, especially having to do with stormwater or wastewater, it may be you've had a dry spell and suddenly there's you see that there's going to be a lot of rain in the forecast. It may be an opportunity. You may have chemicals that you've been storing in one location that you may feel may be best in another location. Or you may be doing some construction, or there's some maintenance that needs to be done that you can actually do ahead of time because you can use these forecasts in what you're doing. And finally, there may be equipment that may be better, like a backup generator or something that's in one place that would better be served in someplace else. And with a forecast like this would be helpful for you in your planning. Next slide. This is just to show you this is from a couple days ago, what it would look like. So day one is in the upper corner, and you can see over the Great Lakes area that there's a lot of storms. Day two, you can see that it's clearing up a bit, and day three, it's pretty much off towards the east. They also have a 5-day total precipitation, and this is looking at the total precipitation over the last 5 days. Next slide. So again, I told you, if you're really excited about this tool, this is the website that you can go to get more information. It's fun to play with. Okay, I guess I'm going now to the Climate Explorer, which is another tool that we have.
Great, thanks, Nancy. We'll pause just to see if there's any questions about the quantitative precipitation forecast tool first. I'm not seeing anything in the chat yet, so we'll just give people a minute, and I'll, if you have any questions, type them in the chat, and I'll use this time to get the next set of slides up. All right, it's looking like we don't have any questions right now on a quantitative precipitation forecast. So Nancy's going to do her next presentation, but when she's done with this, if you have questions on either tools, you can ask about either of them. So, all right, Nancy, you can go ahead with the Climate Explorer.
Okay, thank you very much. This is the Climate Explorer. Again, we're going to do the same thing, show you the website. You're going to go, wow, this is tremendous. And the last slide will have where you could go back and look at it. This is something that's housed on our Climate Resilience Toolkit, which we probably I could talk more about in the tool session. Next slide, please. So this is a really interesting tool. It helps you you can look back in time. You can look at historic observations, modeled data. You can look forward in time as far as future projections. It looks at minimum, maximum, and average temperatures and precipitation totals. And it lets you also set your own thresholds, which I'll show you how to do, that might be important as far as what you're planning on doing. And finally, as I already mentioned, it's part of the larger U.S. Climate Resilience Toolkit. Here's a little plug. If you haven't been to the toolkit, it's an interesting webpage and very useful. You can get information on how to help your community plan for climate changes in your climate area, and also how to talk about resilience. There's sections on case studies. So for example, there's a big section on water, and there's a number of different cities and towns where people have put in how they've used climate tools and how they've helped them or not helped them accordingly. There's also information on the tools themselves, and you can look there for it. There's contact information. There's a lot of information, additional information that can be had there. Okay, next slide. So how to use the tool. It's really simple. You go to the website, You can't really go wrong. You enter in your city or your town or your zip code, excuse me, and then you press go. And then you have a lot of different choices on where to go with it. Next slide. I'm using Ann Arbor as for most of this. I went to school in Ann Arbor and I have a big allegiance for it. So here, this is what will pop up. And let me just say there's 5 different choices here: climate maps, climate charts, high tide flooding, historical weather data, and historical thresholds. And in the case of Ann Arbor, there's no high tide flooding, so I'm not going to demonstrate that today, but it's fairly easy to figure out. Okay, next slide. The first one we're going to do is climate maps. Next slide. If it were me, I'd be doing this quickly. So you have a lot of choices here. In the upper left-hand corner, you can see that you can put in a number of different temperature and precipitation variables. We're going to come back to this, so you don't have to memorize this, but next slide. These are the variables you can choose for the temperature or precipitation. They're handy. You can have daily max, daily minimum temperatures, and you can see here a number of different criteria that can be used as far as what you may want to look up. And they have everything from 90 degrees up or 30 degrees and down. Okay, next slide. The next thing you can do is also set your time period at the bottom as to what you're going to do. This you can't tell yet, but if you notice that half the slide is orange and half the slide is white, and this is a slider. It's a really fun tool, and you can take the slider and go back and forth to see how things change. So in this case, we're talking about historical data, and the historical data there is 1961 to 1990, which is the average on the left-hand side, and that's the white side. And then the more orange side is one under higher emissions standards. I'll talk about lower and higher emission standards in a second. But on this slide, we're just basically showing you that you can compare different time periods, historical modeled, which is the modeling of what happened, higher emission standards and lower emission standards. Let me just talk right now about lower and higher emission standards. Lower standards are the models that have brought together the idea that the heat trapping gases that are entering our atmosphere will be stabilized by 2040, and after that, it's expected that those levels will be reduced. The higher emission standards that are used in this particular tool are ones that where you assume that the global emissions of heat trapping gases will continue increasing up until 2100. Okay, next slide. Oh, I talked about the slider. It's really fun to bring it back and forth and try different things. Okay, then you can choose between whether you want annual information, whether you want spring, summer, fall, or winter. Okay, next slide. The maps can be downloaded, and there's a variety of ways they can be downloaded. And when you download them, you can download the map on the left-hand side, or you can download maps on the right-hand side. Next slide, please. So for instance, if you're interested in trying to just basically get an idea of how to plan for changes in water use compared to what was used before in 1961 to 1990 versus what could happen in 2050 to 2090, I just put those in. Well, I looked at the average daily maximum temperature here, and I said, okay, well, let's just look at the fall, because the fall, the summer you expect the temperatures to be high. Let's just look at the fall. And we know that, the idea is that people tend to use more water in warmer time periods. Well, if you can see a big difference here between what was historical and what you can see for the higher emissions. And on the left-hand side, according to the key, it just shows the change in degrees. And this would be helpful just at least on the surface for you to begin to get an idea of how much things will begin to change. Next slide. So again, you can go back to the start and you can click the choice of climate charts. Next slide. You put in here, and you have to put in again a specific data or the specific point where you want to get it. And again, I put in Ann Arbor. And here you can choose the different, whether you want temperature and precipitation, the way we did before. Next. Yeah, then you can put in again the different emission standards. You can see here in this picture, it's pretty cool. The light gray is what's happened already in the past, because you can see it ends at a particular year. The the pink or red is where the higher emissions expectations are going to be, and the blue are what the lower emissions. And again, this is temperature, so that what you see there is a range. Okay, next. Oh, then we did annual. You could have done it annual or monthly, depending on what your choice is. Next. And you can download the chart and the underlying data for your own use later. And if you have more questions, you can see about the graph. It gives you more information, so you don't have to remember exactly what years what years the higher and lower emission standards are. Next. So again, I said if you are planning for increased water use based on the number of days expected to be over 100 degrees Fahrenheit between now and the future, I just put that in randomly, and this is the chart that came out, and you can see what the expectations are. Next. Okay, the third one we're going to look at is historical weather data. Again, you choose a location, and then you'll get regional and station-based climate information available. Okay, next. So here, this is just to show you how you choose your station. You can go in and out and figure out which ones you want. Okay, next. And this is one that just shows you the normal temperature range versus the actual temperature range on the left-hand side. And on the right-hand side, it just shows you your annual precipitation. Next. Again, you can download the data, the images, the data. This is especially useful if you have to go like before a city council or if you have some kind of citizen group kind of meeting. These charts come in very handy to be able to show the information, the climate information. Okay, next. And so you can also compare, one year to another. And this is like looking at 2011 and 2012. The black lines is what is the normal precipitation patterns. But what's really interesting is 2011, look how much more precipitation occurred. And then in 2012, the same thing, but look how much less precipitation was received. Okay, next. And finally, you have historic thresholds. And this is my favorite part. Okay, next. You can put in here, we've asked for a chart form. It shows the number of times a chosen threshold is chosen. And okay, go next and let me see if I forget what I put in here. Next. Okay, you can choose whether it's going to be precipitation or temperature. And in this threshold in inches, I've chosen precipitation for this one. And I said, okay, let's do 1 inch. Let's see how often 1 inch falls out during this period. Next. And then that's the size of the window for the threshold here in days. How many days hit that threshold of 1 inch? Okay, next. Oh, again, you can download this information. Next. And so I decided, well, let's query it. This could be a lot of fun. So I said, okay, so let's choose precipitation. Let's see how many times the threshold of 1.5 inches has been reached and how many times that threshold has been reached in 2 days. And this is the information and that you have. The x-axis has the years, the y-axis has how many times? I think it's the number of times per year this had occurred. So you can just see how often it rains, 1.5 inches in 2 days. You can change the numbers there, and it was kind of fun to play with. Next. So just to summarize, this tool is very useful for you to be able to look at projected change in your area. You can identify and understand some of the vulnerabilities that your community has. You can also identify areas that you may want to improve to increase your resiliency. It helps you to understand the historic trends, the changes in precipitation and temperature, and then also how often in the past you've exceeded a certain threshold and whether it's something you need to worry about. And you can do this, you can keep looking at it over time to see where it has changed. Next. Again, this is the address of the tool in case you want to play with it some more. Thank you.
All All right, thanks Nancy, and thanks everyone for bearing with us through our technical difficulties. Everything can go great in your practice session, and then you get network connectivity issues day of and have to work around it. So thanks everyone for being patient, but I think we, still got all the information that you needed to get. And if anyone has any questions about either the Climate Explorer or the Quantitative Precipitation Forecast tool for Nancy, we have few more minutes here. You can enter them in the chat box. All right, well, it looks like we don't have any questions, so I'm gonna let everybody take our break a little bit early. So I'm going to come back at 2:05 and we'll have Jason Bernagros presenting on the EPA National Stormwater Calculator. And then after that, we'll have our virtual Tools Cafe session with the breakout rooms. So take the next few minutes to digest and think about maybe which of these tools you're most interested in, and just do whatever you need to do to get ready for the next hour. And then, of course, we'll have another break at 3 o'clock. All right, we'll get back into this. It's 2:06, so, looks like my screen stopped sharing because Jason is ready to go. So we right now have Jason Bernagros of the U.S. EPA Office of Research and Development to present the EPA National Stormwater Calculator, and we allocated a little extra time to this tool just because it's a pretty large comprehensive tool and there's just so much to cover, but we think it's a really valuable resource. So Jason, the screen is yours. You can go ahead and tell us about the Stormwater Calculator.
All right, my name is Jason Bernagros, and I'm with EPA's Office of Research and Development, and I'm going to be going through the National Stormwater Calculator with all of you. So the National Stormwater Calculator, it's available in a web app and a desktop application, and it is a planning tool for green stormwater infrastructure and low impact development projects. So looking at projects that are interested in incorporating some of the most commonly used practices such as green roofs, rain gardens, cisterns, permeable pavement, and you can use it anywhere in the contiguous U.S. And also Puerto Rico, Hawaii, Alaska, and the U.S. Virgin Islands. And the calculator allows a user to be able to look at urban development sites that are less than an acre to about a dozen acres in size. And you can model post-construction stormwater runoff from these sites using alternative scenarios with green stormwater infrastructure, and also looking at changes in historical and projected climate change scenarios. So the Stormwater Calculator, while it is a planning level tool, it does have a very robust urban hydrology model that has been programmed into it called the Stormwater Management Model, also known as SWIM. And SWIM is one of the industry standards for stormwater modeling. And so we have that programmed within the calculator, and the calculator itself is just modeling surface runoff from sites, whereas the full SWIM model can do a lot of other modeling, and it is used more for full municipalities. So I'm going to be demonstrating an application of the calculator using our web app. If you'd like, you can use this URL to bring up the calculator in any internet browser of your choice. And the calculator, the way I like to think of it is we've taken the SWIM model and we've programmed in a bunch of national data sets in order to essentially run SWIM anywhere in the country. And so this is just a list of the different data sets that we use. And actually the way that the calculator runs, you sort of go through each of these data sets one at a time as you're running a project. So I will talk about these in greater detail as I go through this one application. So since this is a Great Lakes focused workshop, I thought that I'd show a project from the Cleveland metro area. This is an actual project that the Northeast Ohio Regional Sewer District has done with its Green Infrastructure Grants program. And the Stormwater Calculator is actually a tool that is used for these projects. So I'm going to be just walking through this specific project using the Stormwater Calculator. So first thing that you do when you open up the calculator is you can type in an address of your site and then put in the size of your project, type in the number of acres. And then next you'll click on the little flower icon on the left and you'll pick out the soil type. And this helps you determine the amount of rainfall runoff for your site. So this is showing a predominantly clay soil type, so high runoff. And next, the water pail is indicating the rate of soil drainage or infiltration for your site. So in this instance, it's showing about 0.1 inches per hour of infiltration. And you'll notice that these polygons are not exactly located at the site, and part of that has to do with the USDA Surgos data set doesn't necessarily have a great wealth of soils data in really urban areas. So we have data a lot of the time on just the outskirts of really dense urban areas. And then the next icon is for topography. And in this instance, shows a flat topography of less than or about a 2% slope. And then the next icon is a rain cloud, which directs you to various NOAA weather stations that we have programmed into the calculator. We have about 8,000 weather stations that have hourly precipitation data and then also potential evapotranspiration data. And what you do here is you can click the nearest weather station to run your analysis. Usually there'll be somewhere between 2 to 5 weather stations that you can click on, and you can look at the period of record for the data if you would like to look at that metadata. And then next, a user enters existing land cover, or it could be proposed land cover for a site, and it's broken up into forest, meadow, lawn, and desert. And then anything that isn't typed in by the user is defaulted to impervious surface cover. So in this instance, we're looking at a parking lot. So a lot typed in 96% of the impervious cover from the site will be managed by bioretention practices, and you can click on any of the LID practices and it'll open up a design window. So pretty basic design windows, but you can put in pre-treatments, or you can actually size the practice to a design storm if you type in a design storm. And then you run the calculator again, and you'll have a side-by-side comparison of what your current scenario is with LID or green infrastructure versus your baseline scenario. And so in this case, there's an estimated reduction of runoff of about 17.43 inches per year. And that equates to, as this part of the Northeast Ohio Regional Sewer District, I'm assuming, has a CSO that they're complying with, so they're reporting things in gallons, and that's why gallons are shown here per year as well. And then this is just showing some of the different summary reports. So we have an extreme rainfall event compared to runoff, and a user can use these different runoff or site reports given what information they're interested in. And I should mention, while I'm not going to show it just now, we also, a couple of years ago, included a cost module for the calculator, and cost is a very important thing with any type of stormwater infrastructure project. So we have data that you can look at what the estimated construction and maintenance costs of your projects are in case that is of interest to you. And with that, this is our website for the calculator. It has our users manuals, and you can download the desktop version of it if you'd like. And you can contact us at swc@epa.gov, or you can contact me directly if you have any questions about the calculator.
All right, thanks, Jason. Does anyone have any immediate questions they want to ask about the stormwater calculator while we have Jason here with all of us? You can type them into the chat box if you do. We don't have any right now, but we'll wait a minute before we start our next section, just in case any questions come in. But after this, we're going to switch over and do our virtual tools cafe, and that's when you'll get to pick which tool you're most interested in hearing more about, and you'll get a little more time to digest the information about it. I know this was a lot of information just thrown at you all at once, so you'll get about 20 minutes or so to actually go to the site of a tool you're interested in, click around, try to use it, ask more questions about it. So if there's no questions, I'll wait maybe another minute before we get into that. Let's see, Nancy just asked for Jason. She said, one of my colleagues asked if there are any error bars.
Not with the runoff numbers in particular. With the cost information, we do have a range of costs that are presented. So there's low, mean, and high costs that bracket the potential errors or the potential range of costs that a project could have given the uncertainty with the cost information or cost data that we have within the calculator.
All right, looks like we have another question. This could go to other people as well. Are there other organizations using the calculator to demonstrate reduction for regulatory purposes that you know of, Jason?
Yeah, so the calculator, I had mentioned one organization that is using the calculator in Cleveland, but it is also used throughout the Great Lakes region by additional municipalities. I think a lot of the time it's used for different green infrastructure grant programs that are helping municipalities with meeting their stormwater regulatory requirements. So the Great Lakes region is a good example of different communities that are using it to support their regulatory programs.
We got one more question and then we'll move on. Is the NOAA Atlas 14 data in the SWIM model for the SMMN model?
Sure. So not currently. I had mentioned we are updating the extreme weather data within the calculator, and we are looking at NOAA Atlas 14 as a potential data set to incorporate into the calculator, and then that data could be used within outside of the calculator with SWIM.
All right, I think we'll stop with questions for now. If anyone else has more questions for Jason, you can go into the breakout room with him, and we'll have 15-20 minutes to demo the Stormwater calculator yourself and ask more questions about it. So thank you, Jason, and thank you to all of our tools presenters today. All right. Thank you all for bearing with us in our technical difficulties, and sorry we're running a little late, but we're gonna get into our final session here, which is our Stormwater Q&A panel that we're gonna wrap up with. And this is mainly intended to provide an opportunity for all of you to ask questions of a variety of different experienced stormwater practitioners on any stormwater topics that you want to know more about. So if this had been in person, we would have asked these speakers to give a presentation on some key area of this and then join the Q&A afterwards, but we didn't want to give you all presentation fatigue and make this into an 8-hour webinar. So we decided to keep it just as an open Q&A and let you all drive the discussion with your own questions. So say you're a city and you're interested in pursuing a certain stormwater plan or policy, and you just want to hear about the experience of someone who's already implemented that plan or policy, use this time to ask about it, and it's very likely that one of our panelists will be able to speak on their experiences with it, or maybe someone else on the webinar can, or they can be more general questions. So if you have a question, we ask that you please submit it in the chat box and we'll read it out. If you have a question that would be easier to ask, I would say you can just write "I have a question" in the chat box, and then we'll call on you. And once we call on you, you can unmute the microphone and ask it. But I would ask that you request that first, so we don't just have a free-for-all with everyone trying to talk over each other. We want to keep it to just our panelists trying to talk. So we also have Matt Nod joining us to moderate this session today. He was formerly the environmental coordinator for the city of Ann Arbor until he retired a few years ago, and he's currently a practitioner in residence with GLISA. He's helping us on our work with cities, and he's much more well-versed in this area than I am, and many of you likely already know him, especially if you do any work with our GLICAN group with the Great Lakes Climate Adaptation Network. He helps run that. So he'll be facilitating the Q&A, and he's prepped some questions in case we get a lull in audience questions. And then for our three speakers, we have Frank Greenland, the Director of Watershed Programs at the Northeast Ohio Regional Sewer District. We have Jerry Hancock, the Stormwater and Floodplain Programs Coordinator for the City of Ann Arbor, and Cameron Davis, Metropolitan Water Reclamation District Commissioner for Greater Chicago. So I'm going to pass it over to Matt, and I know we're running behind, so I'll just ask that our three panelists maybe go in the order that you are on the screen right now and just provide maybe a 2 to 4 minute overview of your background, on your professional role, your career, just to give everyone an idea of your area of expertise and give them some ideas for questions you might be able to address. So I'm going to stop sharing so that we can see all of your screens here, and then I'll put it on gallery view. Then I'll get out of here because you don't need to see me.
Okay, you want me to start? Frank Greenland?
Yep. Do you mind?
Yeah, that'd be great, Frank.
Okay, I'm Frank Greenland. I am the Director of Watershed Programs for the Northeast Ohio Regional Sewer District. I've been with the district for 32 years. My areas of oversight are water quality and industrial surveillance people, our analytical services group, regulatory compliance group, health and safety, GIS, and our stormwater folks, both in our stormwater inspection and maintenance group and watershed programs. My whole career has been about wet weather. Whether it's wet weather issues with local community sewer systems, district interceptors, I was heavily involved in the district's combined sewer overflow program development, as well as wastewater treatment bypass issues, and then we'll talk about the regional stormwater management program. The district, Northeast Ohio Regional Sewer District, was formed by court order in 1972. So we serve about 62, all or parts of 62 communities, about 1 million people in the greater Cleveland area. The court gave us 4 key responsibilities. The first was to operate, maintain, upgrade the 3 largest treatment plants that serve the greater Cleveland area. We took charge of interceptor sewers. We inherited interceptors and have since built additional interceptors about 330 miles. All communities own their local sewers, sanitary, storm, combined. We took on the responsibility for combined sewer overflow control. We're in the midst of a $3 billion Project Clean Lake program to deal with the combined sewer issue. And the last mandate was the regional stormwater management mandate to develop a plan to solve inter-community drainage problems across the district. That program launched in earnest in 2016. It involves 56 communities. It covers multiple watersheds. It focuses on inter-community issues. Streams flow from one community to the next. We prevailed in 3 court. Well, we went 2-1 in the court case. We won the first one, started the program in 13, halted by an appeals court, overturned in 13, went to the Ohio Supreme Court and prevailed in 2015. So we've really been in earnest since 2016. The program involves inspection, maintenance, master planning, design, construction, and a significant amount of community engagement. We charge an impervious area fee for our revenue, collect about $44 million a year. 75% of that revenue is to drive district business functions. 25% is set aside in what we call a community cost share fund for local stormwater work. We approve the work, the communities petition us, and that money's for their local. So it really dovetails well with our regional program. That's all I got.
Thanks, Frank. I think Jerry was next on the slide, so we'll go from east to west.
All right. It's Jerry Hancock. I have a degree in forestry from Michigan Tech and a degree in environmental planning from Eastern Michigan. And that's what I do for the city is environmental planning. I've been at the city for 30 years, and I've had a variety of job titles over the years, but the common theme through all those jobs has been stormwater and floodplain management for that whole time. The city of Ann Arbor does have a stormwater utility, and I'm somewhat of the face of it. If the public has questions about either their impervious area that we are estimating, that we base our charge on, they would contact me. And also credits. We have a credit system for doing things like rain gardens and rain barrels. And again, they would contact me. And on the also on the stormwater side, Ann Arbor is a separated system. We don't have any combined at all. And then on the floodplain side, we are a CRS community. Those who are familiar with that, we are a Class 6, which means everyone who has a flood insurance policy gets 20% discount for our efforts. I'm also very active in the Michigan Stormwater Floodplain Association. I'm actually the executive director of that professional organization. And I think that's about it for right now.
Jerry, I'm going to just, for parallel, Frank talked about how long his program's been in place. So could you do 2 things? How long has Ann Arbor had a utility, and how much do you bring in every year right now?
Okay, so the utility was established in the late 70s. It was changed significantly in 2007 in response to a court case that occurred when the city of Lansing lost theirs. It's called the Bolt case. So we again reassessed it about a year ago and made some adjustments. So been in place since the 70s, but it's had some different rate structures. And right now, our income from the stormwater utility is fairly close to 10 million a year.
Right. Okay, thanks. Kim, do you go by Cam or Cameron?
Cam's fine. Thank you. Well, good afternoon, everybody. My name's Cameron Davis. Call me Cam. Just to introduce myself, right now I'm a commissioner at the Metropolitan Water Reclamation District of Greater Chicago. Like NOAA, which is what Frank was talking about earlier, that's the water and stormwater utility for the Greater Chicago region that covers mostly Cook County, the second largest county in the country. I am, because those are part-time positions, I'm also a full-time staffer at GEI Consultants, where we do work on coastal resilience and green infrastructure as well. Before that, I was a federal employee where I coordinated the work of 11 federal departments, including the White House Council on Environmental Quality, the Department of Homeland Security, Interior, Agriculture, many others, to help run what's called the Great Lakes Restoration Initiative, right now a $300 million annual program to help protect and restore the Great Lakes that we all love. I'm a litigator by training. I lived in and taught at the University of Michigan in Jerry's hometown of Ann Arbor for several years, which I loved a lot. And I got my start as a volunteer back in the 1980s for a nonprofit organization called the Alliance for the Great Lakes, where I ultimately, from 1998 through 2009, served as the president and CEO. So that's a little bit of a background on me. More important than that is the Water Reclamation District itself. It was founded in the late 1800s, largely in response to sewage flowing in the Chicago River out into Lake Michigan, which is the city's drinking water supply. In order to try to protect public health, the state legislature empowered the creation of the what's called now the Water Reclamation District, to help reverse the flow of the Chicago River. Today we have a budget of about $1.1 billion annually, with about 1,800 staff people who work for the agency. And there are two core missions with the agency. One of them is to help with water quality. And so, as we heard from Frank before, that's a pre-treatment program for industrial users. We were also given authority by the state legislature in Illinois, much more recently than that, the ability and the jurisdiction to help the 120 plus communities, including the city of Chicago, with stormwater and flooding related matters. So we have these twin authorities that we work under in order to help protect public health and to help improve the quality of life for Cook County residents. Thank you.
Thank you, Cam. And just again, do you have any kind of dedicated funding for stormwater in particular?
We do. We have, for example, what we call our Phase 2 stormwater project work, where we take applications from municipalities to help reduce stormwater. In fact, right now there is a proposal deadline of August 30th for the most recent round of Phase 2 stormwater funding applications by municipalities. And we can send that link out to anybody who requests it. You can email me at davisc@m, as in Mary, wrd.org. So that's a good example. Another example is something that I'm working on right now, which is to bring green infrastructure to schoolyards. We have a program, we're partners in a program along with many others, called Space to Grow, where we help fund green infrastructure in the city of Chicago. Just in the month of May, I introduced a motion that was unanimously voted on by the entire board to help explore bringing green infrastructure work, including funding, to now suburban Cook County communities as well. And the idea is to bring green infrastructure to schools where they can do a great deal in terms of reducing stormwater, but also education and so many other benefits.
Thank you. Okay, a couple questions so far in our chat box. Ned Gardner was asking, NOAA's doing some work in the Chicago region, and so I think this is Cam. Please comment on regional versus local approaches, particularly rural versus urban.
Sure, I'm glad to take a shot at that, and I'm also happy for others to weigh in as well. I can't speak to what NOAA in particular is doing, but when I think of regional versus local, I really think of regional as the planning effort that's needed in order to try to get, for example, in Cook County, the 120 plus communities to be working together to have to be using a minimum baseline of protection in a consistent manner so that we don't have lopsided stormwater and flooding reduction efforts. And so I really view the planning side as a much more regional approach. And of course, the Metropolitan Water Reclamation District, MWRD, does a lot of work, not just by itself, but in partnership within the Chicago area, the Metropolitan Planning Council, what's called CMAP, the Chicago Metro Agency for Planning, and many, many others. The local is really where the infrastructure work hits the ground, literally. It's where the funding comes together. It's where planning, that regional planning aspect is taken into account in order to design and execute projects that will be implemented locally and make a difference locally as well. The other aspect of the question was rural versus urban. In our urban settings, of course, we have a lot of impervious surfaces like what we heard Frank talking about earlier in the context of Cleveland. And I think the big challenge is to try to turn the impervious into the pervious, the impermeable into the permeable in our urban settings. And of course, rural is where we don't have as many of those kinds of challenges as well. So how do we try to preserve the permeable areas and open spaces that we have in our very urban and suburban settings so that we're relieving residents of stormwater and flooding challenges, not exacerbating them.
Yeah, Frank, I'm wondering whether you want to riff on that as well.
Yeah, I do. We are a regional entity, right? Formed by court order. We're an Ohio Revised Code 6119 entity. And it took us 15 years of discussion to convince the community and our Board of Trustees that a regional approach to stormwater management was the way to go. And we got into court over that because some communities disagreed. And you regionalize anything, I don't care if it's water, fire, sewer, doesn't matter, stormwater, you're going to have a fight on your hands. But in my perspective, I'm a big believer in pace and scale in terms of effort. And I'm also a big believer in dedicating the dollars in master planning, good, sound planning, so that we figure out exactly why are these stormwater problems happening, why do they manifest themselves here, and what's the best solution. And again, I said earlier, ours is, we manage the bigger streams. 300 acres or more of drainage starts our system, and we've got about 476 miles. You can't have a piecemeal community approach and be able to tackle broad watershed stormwater issues and not create additional issues down the road. I think our region and a lot of the nation has been very good at pushing stormwater problems or sewer problems downstream because of the lack of scope, right? The lack of coverage. So we had to convince mayors, 56 mayors, that they're not giving up their, quote, rights at a community level, but we're going to provide them really good service to truly understand why these problems are occurring. Sometimes it's their upstream neighbor we're going to be working in, sometimes it's downstream. But in my estimation, and I've worked with communities for 30 years, it takes, the stars have to align for 6 or 7 communities to chip in for a common problem that's only occurring in one, but all of their drainage is part of the problem. It just doesn't happen. So it was a large fight, but a regional approach, if you can pull it off, helps you fully encompass watersheds and better solve problems at the right price, in my opinion.
No, that's great. And Jerry, you're a little different, but I wonder if you could talk about the idea of, doing it at a city level and where you're seeing the opportunities regionally.
So Ann Arbor sits in the center of Washtenaw County, and we cooperate very closely with the Washtenaw County Water Resource Commissioner, Evan Pratt. And they, over the years, have put together a really progressive set of stormwater rules. They require control of first flush, bankful, 100-year, and there's an infiltration standard now. And they, of course, are using Atlas 14. So very progressive set of rules, and those rules apply over the entire county. So at least in Washtenaw County, we're using the same rules in the city as you would out in the rural areas. We definitely have a different scenario in the city where we're mostly seeing redevelopment. So we, with our redevelopment, basically we are turning sites that used to be mostly impervious with no stormwater management into sites that now have some infiltration and meeting the stormwater management requirements from the county. So redevelopment is actually a really positive thing for us.
So, and Kate's got a question that I want to follow up on, and it's basically, in light of these great climate tools presented today, what are your agencies doing to promote climate resilience, updating ordinances, using climate projections? And then she's asking about obstacles. But Jerry, touch on this idea of, so you've updated local ordinances. So instead of using a FEMA 100-year storm, you're using the Atlas 14 100-year storm, right?
Yes, for our stormwater management requirements, yes.
Right. And just for everybody watching, I think FEMA's 100-year storm is 4.3 inches in 24 hours, and Atlas 14 is 5.1. Full disclosure, I live in Ann Arbor, so that's why I know these numbers. But does the Ann Arbor Stormwater Utility also fund some of that county staff and work? Yes,
we do. Part of our stormwater utility, we give credits for rain gardens, and the city funds about 50% of a rain garden program at the county that assists in by having classes and coordinating the construction of rain gardens on private property. So that is about 50% funded by the city stormwater utility.
Great. I just wanted to kind of give an example of, for an area that doesn't have as strong a regional fundraising capability yet, there is an opportunity for the local and the regional to partner together on some of that. So I think, Jerry, unless you've got something else to add, I don't know whether we want to go to Frank next and just talk about climate and where you're seeing new climate data, climate tools, and what you're doing around climate and resiliency planning.
Okay, I'll touch on that a bit. We use the Atlas 14. We made a concerted effort in the first 5 years of the stormwater program. We wanted to get very detailed master plans accomplished across 4 broad watershed areas. And 3 of them will finish this year, and the last one finishes next year. Now, inherent in all of the master planning was simulation of stream flows and then rainfall gauging, Atlas 14 inputs, all kinds of stuff. The issue for us, is as much what's the future climate as what's today's situation, the historical situation. We have many areas across Northeast Ohio. I'll call it level of service. How many times, what type of repetitive flooding do they see? There are areas that are less than a year, more areas than I would care to have. And then there's certain areas that have very high levels of service. Our goal is to hit a 100-year level of service where we can. We're not going to get there everywhere. The dollars aren't there, the implementability isn't there, but we're using a whole host of tools to try and develop projects that greatly increase level of service. If I can jump from 1 year to 10 for that homeowner, that's a gigantic gain. And then we'll continue to push the envelope. So we're trying to build the resiliency across the district in a stepwise fashion. One thing we are learning, we have very high, record high lake levels on Lake Erie. Interesting thing we're learning, because we're both wastewater and stormwater, the ability of a storm sewer system to discharge into a high stream when the storm sewer is at the bottom of the stream and the stream's 8 foot over that pipe. At the worst time, your discharge ability is compromised. That's a problem, and we don't know what to do about that yet, but that's a problem. It's just like our wastewater treatment plants. You have a very high river level, your ability to push water out over that head is compromised. So that's something we're learning, and we're just going to have to do a better job of figuring out how do we handle that. There's more work to come on that.
Thanks, Frank. And Cam, how is your, metropolitan area district kind of starting to build climate and resilience into your planning?
Sure. Thank you for the question. We rely on the Illinois State Water Survey, which is an agency that does a great deal of the water-based science work in the state. And we use something called Bulletin 70, that's Bulletin 70, which looks at rainfall patterns around the state. And in particular, that has become the climate-based underpinning to what we call our watershed management ordinance. Everything needs an acronym in our world, so the WMO, the Watershed Management Ordinance. And the Watershed Management Ordinance has been around since 2014. We revised it again last year and then amended it again this year, in part because we want to keep updating it to keep reflecting the latest work and the latest science that's informing us on climate change and climate change patterns as it relates to stormwater. One of the things that we have now done is built into this watershed management ordinance specific direction for not only looking at climate change and its impact on stormwater in the region, but we have also amended the watershed management ordinance to specifically require that we factor in disproportionately impacted communities or disproportionately impacted areas, as we call them, when we do our watershed planning based in large part on what climate change is starting to do. We've also built in a pilot project to take a look at stormwater trading and many other components as well that will help not just lay the groundwork for what we call flow rates, that is water running off of somebody's property and trying to limit that, but make sure that we're continually looking forward and adapting the watershed management ordinance based on the latest science so that we can stay ahead of climate change, not stuck behind it.
No, that's great. And Cam, I'm going to call on you next because you brought it up and we've got a question about it. Nora is asking about directing funds to address historical effects of racism that's put communities of color in higher flood risk. So you started talking about vulnerable communities and starting to take a more intentional focus on that. So why don't we talk about that just a little bit more, and then we'll go back around and catch what's happening in these other groups.
Perfect. Yeah, and Nora's question was exactly the reason this kind of history of racism and disproportionately impacted communities that the watershed ordinance. And there are, that's a much longer conversation that could probably take up a lot of our chat right now. But the idea is that we would look at disproportionately impacted areas, as we call them, in prioritizing funds for stormwater reduction projects. And in some ways, the district has already been doing some of that work. For example, it would look at economically disconnected communities. It would look at median household incomes, all factored into this this regimen of how we prioritize stormwater reduction in the area. So this amendment to our watershed management ordinance that we unanimously passed last year and again updated this year will take that and basically take that thinking and that work and amplify it and accelerate it.
Thank you. Frank.
Okay, I'll touch on this. I'll hit a couple. The lay of the land in our stormwater utility is that we take on water from northern Summit County and a ton of Cuyahoga County communities. And all of that water flows north to Lake Erie. Everything within the service area is going to Lake Erie. As you roll closer to the lake, the streams get larger, the problems get bigger, and the disadvantaged community tends to surround these streams where the problems are the biggest. So we're very conscious of the enormity of these problems, the lay of the land, the folks living in these areas, and have made a very concerted effort to start developing and implementing solutions to solve stormwater flooding problems that many times it can be street flooding, yard flooding, or it's going to be basement flooding, gets into the basement. So the beauty of the master plans is we're not shying away from huge, huge projects. Sometimes those projects require some voluntary land acquisitions, and we work with our local mayors on that and have been pretty successful, and we've been able to create some really nice projects. We have also done sanitary sewer evaluation surveys across all of our member communities. We're still doing them to identify overflow and basement flooding issues. And the same lay of the land. When you get to the downstream areas, we're talking Cleveland and certain inner ring suburbs, much more of a poverty situation in those areas. We have what we call a member community infrastructure grant program, where we provide funding. There's certain community match requirements, but they can be waived for those communities in fiscal distress. And these funds are geared at solving longstanding problems that are affecting those communities, particularly basement flooding. I think the best part of this program is we've been able to completely rebuild infrastructure, storm and sanitary sewers, get rid of combined sewers in very disadvantaged communities. I mean, they have a brand new sewer system, street, and service to the communities, and we're really big on that, and we're going to hopefully continue that going forward.
And Frank, just to touch on that, and that's because you now have a dedicated funding source, right?
Well, that member community infrastructure grant program is wastewater funded. Our board, for a 5-year period, agreed to set aside some funding to start to stimulate local sanitary combined sewer efforts geared at solving these longstanding problems, because there's no free money out there, right? There's no free money.
Right.
And the communities, their ability to incur debt is limited. So this really has stimulated a lot of basement flooding, relief projects, failing septic tank conversion projects, and the like. So we have that on the wastewater side. The stormwater side, each community has their share of money, all of them. Depends on revenue collection. And some of the disadvantaged areas, pretty large revenue collection. So their local pots of money are correspondingly large. So if we can get local projects done to couple with the regional projects we're doing in these areas, all the better. And it's working really, really well.
Jerry, I want to make sure, and Kim, you let us know when our time's up. I see we've got like 6 minutes before 4 o'clock, but Jerry, do you want to touch on the equity issues and anything that Ann Arbor's doing in that space or that you can talk about in the county?
Yeah, I can give one really good example. The city stormwater fund, one of the things that we do with the money is it pays for tree planting. And in a forestry study that we did, we took a look at the economics and social aspects of the communities, and we prioritized the most disadvantaged communities as being at the top of the list for tree planting. So kind of flipped the thing from the squeaky wheel to the people who aren't having their voices heard as much.
Right, that's a good example. And just when you have a stormwater requirement, can you talk about residential versus commercial? In other words, if somebody's building on a residential site, they also have mitigation requirements as well, right?
Yes. So anything other than a single or two family house would have to follow our full-blown set of regulations. And typically in most communities, building single family would be like exempt, but we actually require, it's not nearly as much, but we require control of the first flush for the increase in impervious on residential property.
So if you're going to add more than 200 square feet?
Yep. If you put in more than 200 square feet of new impervious, then you have to control first flush for the new area. So, so if you're rebuilding, you're tearing a house down and rebuilding it, maybe you only have a 500 square foot increase. So we only require control of that for right now.
Yep. No, I just highlight it because a lot of the Ann Arbor space is residential. And so if you ignore that, there's a lot of your space you're not mitigating down the road. We only have about 1 more minute for, and then, we need to wrap it up. So we've got some folks interested in Jerry's plans on rain gardens and storm barrels. I think if you go to the Ann Arbor website, you can, and Google Stormwater, you'll be able to find all your stuff. And all of you have websites I think are going to be useful. Let's see, maybe let's stop with the questions. There's a few more, but each take 1 minute just to say, where do you see the future, either on this equity issue, on the financing, on the regional cooperation? Is there good news that you think is heading our way or in your area or something you would look forward to? Let's start with Frank.
Well, I look forward to more of this, right? Whether it's local or regional. And it's a tough fight, to get any fee, any revenue is a tough fight. To stand pat is a losing match, right? We're all in the infrastructure management business. Nothing gets newer. Your house doesn't get newer. You've got to put some dollars into it. The sewers sure aren't getting any newer. And stormwater management is really a big deal, I think, for any community. And it's getting more of a big deal. It used to be a phase 2 issue, way more than that, because it intersects and comes over to your wastewater side. And if you can't handle stormwater effectively, you will not handle wastewater effectively either. So I hope for more, but it's going to be a tough battle. It takes resources.
Right. Yeah. Cam.
Sure, thanks, Matt. You know, one thing that I'm excited about and I'm contemplating is a concept called the Community Conservation Corps, where we try to take land that the Metropolitan Water Reclamation District owns, meaning the taxpayers own, and do more with it to reduce stormwater, while at the same time trying to get secondary uses out of that property as well. We in the Cook County region, like so many other urban regions, have food desert problems, for example. So my working theory right now is I try to develop this idea, and I welcome the help from anybody who's on the webinar here today. My working theory is that we can take this property, reduce stormwater, and get secondary benefits out of it that help in terms of equity, giving people access to healthy, inexpensive food where we have food deserts. So I think it's up to us to innovate in this world of municipal stormwater management, and that's certainly something that I'm real eager to hear from others about as well. Thank you.
No, perfect. Thank you, Cam. That's a great idea, that idea of how do you integrate co-benefits in all this work that we're doing. Jerry.
Earlier today, in one of the presentations about Atlas 14, there was mention that the 500-year storm used to be the 100, I got it backwards, the 100-year storm used to be the 500-year. And I actually used that here in Ann Arbor for an ordinance that I have proposed. I'm going through the Planning Commission right now to change our floodplain ordinance and require elevation above the 500 instead of the 100. And that statistic that was mentioned earlier in this presentation is the exact reason that we've justified requiring that further elevation. And you were asking, like, what am I hopeful in the future about? So since I'm talking about floodplain management, FEMA is in the process of redoing their rate structure for flood insurance, and I think this will have a very positive benefit of encouraging people not to build in floodplains, because the flood insurance rates are going to be moving towards actuary rates. So I'm very hopeful for that, that FEMA will come through.
Oh, that's great. And I'm going to toss one bone to Ann Arbor. If you haven't seen it, Jerry just finished a project that was going on for about 8 to 10 years, where in a low spot by the river, they blew a hole in a railroad berm that was really difficult to work with the railroad and get them to let you put a big hole underneath where the Ann Arbor Chicago rail goes. But it dropped the floodplain significantly in that area. And so it's one of those things where it's just something I watched as an outsider for a long time that was a good idea that became a, what, $8-9 million project, Jerry?
Yeah, $9 million project.
But dropped the floodplain how far in that neighborhood?
6.5 feet.
So bunch of homeowners don't have to pay flood insurance. So again, having staff and funding that you can put towards this, you can see some real changes go on in these communities. And I'm sure all of you have stories as well. And sorry to toss that one in there, but I just thought it was a good recent one. Kim, I know we're over a little bit, but do you want to wrap this up? And other than that, I want to just really thank our 3 presenters from communities big and small, regionally elected, and staff. I think it was a great set of stories that you were able to share with this group of, at one point, well over 100 people listening in. So Kim, thanks so much.
Yes, thank you so much, Matt, for moderating that. You did a great job. And thank you to Cam, Jerry, and Frank. I thought that was a really interesting discussion. And that's really why we decided to add this session at the end, is because we didn't want this 3-hour webinar to just be about tools and listening to tool presentations. We wanted some bigger picture discussion to go along with it. So I thought I got a lot out of that discussion. I hope the rest of you did, who have stuck with us into our 3rd hour here, going a little bit over. I promise I'll wrap it up here. I just want to take a minute to thank all of our tools presenters, our panelists that you just heard from, our steering committee who helped in the initial planning stages, all of the GLISA staff, students, and faculty who have helped me pull this off today, technical glitches aside. And thank you all of us for joining us today. We had a really great turnout, way more than we expected, and I think the NOAA leads on this project will be able to take the feedback that they got from that survey and really use it to inform some of their future plans for those tools. So in a few weeks, we're going to post the full recording of this webinar, and I'll send out an email when this is the case. So if you need to refer back to it for something, or you want to send it to a colleague who couldn't attend, and I'll be sending out a follow-up email later this week, and it will have a number of things in it. It will have all the slides from today that you've seen. It will have that tools overview document that I mentioned earlier. It will have a link to the optional post survey with and the option for more short answer responses if you have time to give a little more in-depth feedback on the tools. And there's also another webinar coming up in late August that you all may be interested in. It will be a webinar on water equity in the Great Lakes, hosted by the U.S. Water Alliance in partnership with Sea Grant and the NOAA Climate Program Office. So once I find out a little bit more information about that, I will send it out in a follow-up email. I'm not sure if it's late August or early September, but I will let you know, because I think based on some of the discussion during that panel, I think that would be a webinar of interest to some of you. And please don't hesitate to reach out to me with any questions, whether it's about this webinar, about the tools, to get in contact with any of the speakers, or if you just have questions about climate information in general or anything GLISA related. You have my email here, and you can also reply directly to any of those notification emails that you've been getting about this webinar. It says it comes from GLISA, but if you reply, it comes straight to my email, so you can contact me that way as well. So I know we're a little bit over. Thank you to those of you who stuck with us the whole 3 hours. I'm pretty impressed. I'll stay on for an extra few minutes just in case we have any lingering questions, but we'll let you all go. And thank you so much for joining us, and I hope you all have a wonderful rest of your day.